All right, everybody, welcome in. I think we're set. I think we're good. Okay, so welcome in. Let's see. Before I forget, one thing I want to mention is that I have to go onto campus today for my office hours, so I might be a few minutes late. I will stick around after class so that any of you who want to ask me questions, I will stick around as long as anyone's asking me questions. But if your plan was to come back during office hours, I might be a few minutes late because I have to actually get to campus. My department head has requested some documents for some projects I was working on pre-pandemic, and those documents are on my office computer. So I need to get in there so she can have those documents. And I'll just bring my iPad and I will have a Zoom meeting there at work. At least for part of the time, I may be able to get myself back home. So if you tune into office hours today and I'm not there, just check back 30 minutes later and I might be. But today's kind of a weird day. My dog is also being neutered, so I may have to go pick up my dog when they say that he's all ready to go. So it's kind of a strange day, but I should be around in office hours if you need to talk to me. Otherwise, my other office hours should be normal through the rest of the week. Of course, not including Thursday because we all have Thursday off, right? Okay, so we're continuing with our discussion from last time, right? And I'll definitely be showing you how to work some problems. Whoops, why did this not? Weird, it compiled early. Completing the square, there we go. So, and if anyone has questions, as usual, you'll be able to see more visually on the YouTube stream than you are on the iPad. But you're welcome to consume these in whichever way you like. So I will be showing you some stuff. We're expanding beyond what we did last time. So there's kind of three stages, right? In this chapter, there's the square root property, which we talked about last time. And then from the square root property, we build this thing called completing the square. And then we get kind of tired of completing the square and we're like, what a pain. This is kind of annoying to do this problem this way. Isn't there a shorter way to do this problem? And the answer is yes. So then we take completing the square, and from that we create the quadratic formula, which isn't that much better. It's a little better, it's preferred by most people, but it's even quadratic formula is not exactly a one-line problem. You still have quite a bit of simplifying and stuff like that to do. So that's where we're going. But the quadratic formula is hugely important because it will always work, right? That's the nice thing about it. The payoff, or the price we have to pay, is that it's not really fun to do those problems, and they tend to get lengthy, and there's many places where if you're not paying attention, a little sign error can throw the entire problem way off. So, they're not fun to do that way, but they work every time. So that's what's nice about it. So going forward, generally what you'll do, and I don't even know if we'll get to quadratic formula today. It depends how much time we're going to spend on completing the square, because that's a really important topic too. But what's going to happen is actually by the end of today, you will be able to solve every quadratic formula. Completing the square can solve every quadratic equation that you run across. Factoring can't. So generally, factoring is an easier process. If you're going to solve an equation by factoring like we did in the last chapter, that's going to be easier than completing the square. Okay, well, great. If we have an easier way of doing it, then why don't we just use that? Well, because there are many quadratic equations that cannot be solved by factoring because the polynomials themselves are not factorable. So what you're going to do when someone gives you a quadratic equation is you take it and go, and you have to solve it. You take it and go, okay, is this factorable? Can I factor this? Oh, good, I can. This problem's going to be easy. Or you take it and go, okay, is this factorable? No, it doesn't look like it. Darn it. I'm going to have to use either completing the square or the quadratic formula. Most people opt for the quadratic formula. So that's kind of the structure of this chapter. We take the square root property, which is the foundation of the entire chapter. Without the square root property, the whole chapter falls apart. Luckily, we have the square root property. That's the base, the foundation. We build completing the square, and then we streamline it to get the quadratic formula. So you might go, well, then so what I'm hearing is completing the square is not that important. No. Unfortunately, completing the square is very important. You might go, well, but didn't you just say that we could use the quadratic formula instead and that's easier? Yeah. The problem is that the process of completing the square gets used in other areas of mathematics as well, in other areas of algebra. And when you run across those in those other instances, the quadratic formula is not going to get you out of it. It's not going to fix it for you. So for this particular chapter, yeah, you can use the quadratic formula to solve an equation. But when we get into conics and you have to manipulate things into the right process so that it fits your formula, completing the square. And quadratic formula doesn't even make sense in that context. So completing the square gets used in other areas of mathematics. So if you learn it now, you kind of get those other topics for free, right? Because if you get comfortable with completing the square, not only will you be able to do the completing the square problems correctly, but then when we get to conics, there's this clear divide. The students who understand completing the square and they're able to do the conics problems, and the ones who never quite learned completing the square, and then conics doesn't make any sense to them because they can't do the algebra necessary to solve the conics. So that's kind of where we're at with that situation, is that you need it for other stuff too. So I know it's a pain, and some students kind of talk themselves into, well, I'll just skip this topic. I don't really get it. But if you skip it, you're kind of, it's like triple damage, because you can't do completing the square. You're not going to be able to do conics. You're not going to be able to do, trying to remember, I think it comes up at least one other place, but I can't think of it off the top of my head. You're going to have trouble in all three of those areas. So you're kind of better off just learn completing the square, learn quadratic formula, then you'll be good at them. And when you need to know how to do those things, you'll be able to do it. Okay? So that's kind of where we're at. So let's just, as a reminder, let's go through a square root property problem so we can remember how those work, like we looked at last time. So let's take a look like a problem like this. Okay, so let's solve this thing using the square root property, because like I said, the square root property is the basis for completing the square. So we want to make sure we remember how the square root property works, so that when I apply completing the square to it, you go, oh, okay, I see how this is just a continuation of that last procedure that we looked at. So what, 2, 5x minus 3. So we've got 2, 5x minus 3 squared minus 14 equals 16. Did I get that right? Probably not. Nope, plus 14. Almost got it. So 2 times 5x minus 3 squared plus 14 equals 16. 2 times 5 minus 3 squared plus 14 equals 16. And like always, it's totally worth your time. Like, see how I'm double checking that I wrote the thing down correctly? It's totally worth your time, because I'll tell you, I see it all the time in class where a student's like, I don't know, I can't get this problem right. What's going on? And we go back, they were like, I've done this like 5 times. I swear I'm doing it right. Why is it wrong? And then we go back. It's because they wrote the problem down wrong from the book or from the computer or whatever. Like I originally had this as a minus 14 instead of a plus. That one thing means you're going to get your answer is going to keep coming out wrong. So just double check you wrote it down right. Looks like I did. Okay, so let's get to work. So first step, we need to get 0 on one side of the equals. Sorry. Wrong procedure. We need to get the part that's being squared, we need to get that isolated on one side of the equal sign. So, okay, let's take care of that 14. So this next line is going to be 2 times 5x minus 3 quantity squared equals 2, right? Because I subtracted 14 from both sides. Okay, so we get this. Now I'm going to divide both sides by 2. Leaving me with 5x minus 3 quantity squared equals 1. So I divided both sides of the equation by 2 to get this. And now remember, we're going to use that square root property, which says that, okay, basically, and I'll see students doing this, and I even got it, I think somebody said this to me the other day, where they say, oh, I'm taking the square root of both sides. Not really. You're not taking the square root of both sides. I mean, in a sense, you could make that argument that you're taking the square root of both sides, but it's a little more complicated than that, because what I find is when students say, oh, well, now I'll just take the square root of both sides, what happens is they forget that there's two answers. There's the plus version and there's the minus version of it, right? So let's just remind ourselves what that property says. Make sure I get the wording exactly right. We've got, this means that 5x minus 3 is going to equal, then we do take the square root. You could argue in some sense we're taking the square root of both sides, but I feel like that narrative, that description is leaving out part of what we're doing, and then that leaves students to leave out the second answer, right? So when we apply that square root property, we say that if x squared equals c, so this is our squared part equaling a number, then x is equal to the square root of c, or x is equal to the negative square root of c. So that would mean that we would say, so 5x minus 3 equals the square root of 1, which is a pretty easy one to simplify, or 5x minus 3 equals negative square root of 1. Forgot my backslash there. Okay, well, the square root of 1 is 1, and the negative square root of 1 is negative 1. So in this case, it's pretty easy to simplify these. So let's take a look here. So that's going to be 5x minus 3 equals 1, or 5x minus 3 equals negative 1. Okay, now each of these equations pretty easy to solve. So let's see. Let's take the first one. So if I add 3 to both sides, I get 5x equals 4. Right? If I add 3 right here and I add 3 here, I get 5x equals 4, which leads us then to conclude, if I haven't made any mistakes here, that x equals the fraction 4/5. Okay, so 4/5 should be an answer if I didn't mess anything up. And the other one, if I take the other equation, let's see, if I add 4 over here, I get 2. So 5x equals 2. 5x equals 2. Okay, so I get that x equals the fraction. That's going to be what, 2/5? 2/5. That's a little harder to check these by hand when they're fractions. You can, but I guess I'm going to gamble. I kind of think I got this right. So let's see if we did. But if you're not sure and you don't want to have that, also the difference is I don't actually have to complete the homework. So if it tells me I'm wrong, I don't have that penalty like you do at home where you have to do extra problems when you get it wrong. So it's up to you how motivated you are to actually plug those fractional values in and check them. But let's see, what did I get? 4/5 and 2/5, and we'll cross our fingers. All right, I got it. Good. So, but it's easy to make a mistake. So you might be like, what do you mean maybe you did it wrong? There's lots of places in this problem where I could have made a mistake with my negatives, with my adding one of the signs, the square root part. Lots of easy places, lots of places to make little easy mistakes to make. So you want to kind of be careful. But I did get it right here. I kind of felt like it was right. So they did the same thing, subtracted 14, divided by 2, square root property. They even kind of say here square root both sides, but technically we're taking the square root property. Okay, so you can say you're squaring both sides or square rooting both sides as long as you realize you're using the square root property and you do it correctly. I just see a lot of students say, oh, well, I took the square root of both sides, and then they only get the one answer instead of the two that you're supposed to get. Well, then you shouldn't say that, okay? You do the work and you get down to the bottom. So that is the square root property. That's what we spent last time talking about, okay? So that's great when you have something that you can get in this form of something squared equaling 1, where this thing over here has to be a number, and the thing in here should be an algebraic expression being squared. What about when we don't have that? What about when we have something that can't be written in that form, or we can't figure out how to write it in that form? Well, then we have this technique for manipulating our algebraic equation, which we call completing the square. It makes sense if we have something like, let me find the problem I wanted to do here. Okay, so take, for example, x squared minus 4x plus 16 equals 0. This problem, we can, well, technically we can. That's the whole point of completing the square. But by looking at this, we say, well, how can I put that in the square root property form so that I can use that square root property? And we look at it and say, well, here's something being squared, and here's a number. So if this 4x wasn't here, I could put the x squared on one side and the 16 on the other, and then I could use the square root property. But unfortunately, we do have to deal with this negative 4x. We can't just pretend like that negative 4x isn't there. Some students decide to pretend like the negative 4x isn't there, but then guess what? You're doing it wrong. So it becomes a lot more complicated to put this in this form that we like of some quantity being squared equaling a number. So how do we do that? How do I get this in the right form? Well, that's where completing the square comes in. All completing the square is like, people will do these long problems called completing the square, and they're like, oh, that's so tedious, and it is. But what they don't realize is the second half of the problem is just the square root property. So if you've already sat down and done the homework and you understand the square root property, you understand the whole second half of completing the square. What completing the square does is it takes something like this, and we're going to algebraically manipulate it to put it in the right form so that we can use the square root property. That's all it is like, man, this thing's not in the right form. I can't apply the square root property. Okay, we'll do completing the square, and then you can apply the square root property. That's what it comes down to. So completing the square is one of these processes that when people first see it, they're like, oh God, this sucks. This is like kind of tedious. I have to remember all these little details all the way along the way. But then what you find is every single completing the square problem, it's like the exact same. Like the numbers change, obviously, but like every step you're like, okay, now is the step where I take half of this coefficient. Now is the step where I square it. Now's the thing. So the fact that it's like identical every single time is super boring, but it's also the thing that's going to eventually give us the power to create a formula and shortcut this a little bit. So that's the idea. What we're about to do is just so that I can force this quadratic equation into the form where we can apply the square root property. And I'll point it out as we go. Now, the directions that I'm giving, you're going to go, where are these directions coming from? Where are you coming up with this? It's just the square root property. So you just have to memorize the steps for the square root property. And hopefully you even get to the point where you understand why we're doing them, because you'll see, oh, I see. It's like, if you understand factoring really well, then you're more likely to go, oh, I see what's going on when we complete the square. I see what's happening there. And then you won't forget it, right? So here's what we're going to do. We're going to get the 16 on the side by itself. So remember, for square root property, we want the number on the right side. So I'm going to do that. So step 1, I'm putting the number on the right side. Right, and I can even say, constant on the right. All right, constant on the right. So that was the point of that step. I got the constant term on the right by subtracting 16 from both sides. Okay, now what? Well, now what we need to do is figure out how to write that thing on the left as a perfect square, as some quantity being squared. Okay, so what we're going to look at is there some way that I could introduce a value that makes this a perfect square trinomial? And there's a method for doing that, which is always going to work. You take half the coefficient on your x term and you square it. So half of -4 is -2. -2 squared is 4. So I'm just going to write that actually. So this is kind of the key to the whole thing. If you can remember this part, you can probably finish it. So half the x coefficient squared. Right, that's where we got this from. You take your coefficient is the term that has an x, that's the x term. The coefficient on that is -4. That's what we're looking at. So half of -4 is -2. -2 squared is 4. So I'm going to add 4 to both sides of the equation. Okay, do you see how I have this earlier equation, but now I've added 4 to both sides? Wait, where did 4 come from? It's half the x coefficient squared, right? So you look here at this middle x, the x term. We take the coefficient, we cut it in half, and we square it. Why does that work? Just think about how your FOIL works, right? If this is going to, because we designed it this way, the thing on the left is now going to factor as a perfect square, right? So watch. The thing on the left becomes x minus 2 squared equals 20. And we go, wait, well, how did you do that? You just factored this. You did a chapter of all factoring. I factored this, right? You do your, this is x minus 2 times x minus 2 gives you this. I go, well, how did you know that? It's because we forced it to happen. When we took half this x coefficient and squared it, if you just think about the way you go through and you do your FOIL, your first, outer, inner, last, the last is the product of the two constants in your factors. If they're the same thing, then it's the same as that number squared. And the middle is the sum. So if we cut the middle term in half and square it, we are creating a perfect square trinomial. And once we do that, we can factor it as a perfect square. So the whole thing hinges on us being able to remember half the x coefficient squared will make the problem come out the way we want. So this is the new part. What we just did is the new part. The rest of the problem you know how to do. We did it last time. It's the perfect square. It's the square root property, right? Like once we're in this form, we just did a problem similar to this at the beginning of the class, right? And we spent all last class doing this. So once you get to this point, you go, oh, I know how to finish these, right? Because we already did it. It's this first step that people really kind of get hung up on and confused about. So don't overthink it. We're not learning a whole big new process. We're just learning these first 3 steps to get something in the right form. Now that it's in the right form, let's go from here. So now we're going to have what? So using the square root property, this will say that x minus 2 equals, and I'm going to use the plus or minus symbol just to keep it so that otherwise it gets kind of long on the screen, plus or minus square root of 20. Okay, then we go, wait a minute, I got to figure out, oops. Okay, but man, now I got to simplify square root of 20. Well, remember, square root of 20 breaks down as square root of 4, square root of 5, and square root of 4 is 2. right? So x minus 2 equals plus or minus 2 square root of 5. If you don't remember how to break down square root of 20, go back and check those problems a little bit. You should remember pretty quickly. But again, square root of 20 is square root of 4 times square root of 5. Square root of 4, we all know, is 2. Right? All right, and then, oh, here we go. Look, I messed up. I knew something was wrong. Look, I have a typo here. When I went from in my equation, I went from negative 16 to positive 16. And I got to go back and fix that. See how easy it is to make these mistakes? Just a simple negative sign that you miss is going to screw it all up. So let me go back. So this should be a negative 16 plus 4, which should make this a negative 12, which should make this, oh, so now my simplifying is all messed up here. So let's see. That's going to become square root of 4 square root of 3. So this is going to become 2i times the square root of 3, right? Yeah. Which means this one down here becomes square root of 3, and it's 2i. But then it's really, if I add 2 to both sides, I get 2 plus or minus. So sorry about that mistake, but they're easy to make in these. Like, trust me, it's easy to do. So once we got to this point with the square root property, what did I do? I had an algebraic expression squared equals negative 12. So I now use the square root property. If I take the square root of negative 12, I get the square root of negative 1 times the square root of, here, I'll just write it because there's a lot going on there. So x minus 2 squared equals the square root of negative 1 times the square root of 4 times the square root of 3. Okay, so it's negative 12, right, when we, oops, this should be after I took the square root property. Okay, so once I took the square root property, it means these get a little harder to type too, so I'm trying to do it in a way. Okay, so x minus 2 equals plus or minus the simplification of the square root of negative 12 is square root of negative 1, square root of 4, square root of 3. The square root of negative 1 becomes I. Remember we spent that day on complex numbers? The square root of negative 1 is I. That's where the I comes from. The square root of 4 is 2. That's where the 2 comes from. The square root of 3 is fully simplified. That's where that comes from. Okay, so these problems can be confusing for students because they really are going to test you on a number of previous topics. They're going to test you on how well you did in that chapter on square roots. They're going to test you on complex numbers. They're going to test you on simplifying roots, fractions. A whole bunch of stuff comes up in this chapter. So you kind of got to be good at all those pieces. So we simplify that to be plus or minus 2i square root of 3, and then we just add 2 to both sides, and we get 2 plus or minus 2i root 3, and that's the answer for how that one's done. So this is a completing the square problem, and there's a lot to it, right? I'm not going to sit here and tell you, like, see how simple it is? Like, there's stuff to keep track of. You have to remember how to do completing the square, which is that whole take half the x coefficient and square it term. Then you got to not have a typo like I did where I left out a negative and it messed up the problem a little bit. So I had to go back and fix that. You have to be good with your simplification of roots. You have to remember complex numbers. You got to understand this plus or minus symbol. You know, there's stuff going on there. There's stuff going on. So let's see about doing an actual problem here. Okay. So here they're kind of, you're sort of dipping your toe into the pool of completing the square, right? And so no one's just shoving you into the deep end and then watching you either sink or swim. They're kind of setting you up for that step, that key step that I've been talking about, which is the half the x coefficient squared, this piece right here. You're going to have some homework problems where they have you do that. So if using the method of completing the square to solve the quadratic equation, x squared plus 13x minus 3 equals 0, which number would have to be added to complete the square? Well, this is where you calculate half the x coefficient squared. So you go, wait a minute, that 13's an odd number. If I have it, I'm going to get a fraction. Yeah, it sucks. Sometimes you get a fraction. So let's see. So half this coefficient should be 13 halves, and you square that, it should be 169 fourths. So I believe, let's see, should be 169 fourths. Yeah, got it right here. So it's the same thing I've been talking about. You take 13 halves, which you can write as 6.5 if you want. But why? I know people don't like fractions, but decimals tend to be worse. So I just squared the 13 halves, and that's where I got the 169 fourths down here. They're saying you can also do it as a decimal. Yeah, sometimes you can. So 42.25 also would have been an answer that they would have taken, but I would encourage you to use the fractions. It's not wrong if you use the decimals. People feel more comfortable with decimals, but what I find is people are actually, it's weird. People feel uncomfortable with fractions but comfortable with decimals. But when I look at people's ability, they tend to be better with fractions than they are with decimals, which is strange. But I think it's just because, you know, when someone says 42.25, you kind of know. You're like, okay, a little more than 42. But if someone says 169 fourths, you're like, well, how much is that? Is that like bigger than 20? Is that bigger than 30? It's not quite as clear, right? But the reason we use fractions most of the time is because the calculations are better. A little better to use those. Okay, so see how it's not too bad once you get the hang of it, okay? What about for this one? Well, half the coefficient on x would be, so you take 3, cut it in half, so that's 3 halves. When you square a fraction, remember you just square the top, square the bottom. So 3 halves squared would be 9 fourths. Enter. And we got it, right? So when you do these problems, you start to go, oh, these actually aren't too bad. Like, I'm just taking half that x coefficient and squaring it. Yeah, that's what you're doing for part. That's setting up the completing the square. That's not the whole problem. But you'll have some homework problems like that where they say, yeah, just the part 1 of the method. Okay. Let's do one of these. Oh, wait, that's not what I want. Here we go. Let's do this one. Okay, solve the equation. So solve the equation for all values of x by completing the square. So sometimes they're going to give you problems. Let's see. I think this one might be factorable. If it's -6, wouldn't that be -5, -1? They're going to give you problems that are simpler. And students go, well, but I can just do this with factoring. So shouldn't I do that? Well, no, because we're giving you these problems and telling you to use completing the square so that you're first using completing the square on some simpler problems. Then when we get into the harder problems, you'll know what to do. I think I talked about this before. I think it was this class. We talked about process. A lot of times students, when we give them an easy problem, they'll just do it in their head or they'll know how to do it, but they don't really think about the process. So they're like, oh, well, the answer is this, whatever. Why are we spending time on this? But then when they get to the harder problems, they don't know how to do them because they didn't practice the process. They thought the problem was about getting the answer, when math class is not about getting the answer. Math class is about learning the process. Like, who cares what the answer to this is? Are any of our lives going to change because we know what the answer to this equation is? No. But if you know the process for completing the square, that may change your life because it may mean that you pass this class and then you can move on and then you want to be an engineer and you can make it through calculus and, you know, all that kind of stuff. So the process is what's important, not the answer. But a lot of students don't get that. They're like, no, what matters is that, you know, if I look in the back of the book, it has the same same answer that I got, that's not really what's important. Okay, so kind of keep your eye on the prize. Okay, so x squared plus 5 equals 6x. X squared plus 5 equals 6x. We're going to solve that. Okay, well, what do I need in my first round of formatting? I really need the constant over here, and I need this x over on the left with the x squared. So I'm just going to subtract 5, and I'm going to subtract 6x. So that should give us that x squared minus 6x equals negative 5. Now you might be saying, can I factor this? I think this one you can factor, but again, what the whole purpose of this problem is not to solve it using the wrong method or a different method. It's to solve it so we can see how that process works on a simple problem, so that you can go, okay, I kind of see the pattern here. Okay, so what am I going to add to both sides? I'm going to give you just a second, just to yourself in your head. Try to figure out what is the value that I'm going to add to both sides of the equation. Okay, hopefully you got that you were going to add 9 to both sides. 9, right? Like those problems we just did a minute ago on delta math. We're going to take half this x coefficient, so half of that is negative 3. Negative 3 squared is 9. I'm going to add 9 to both sides. So that becomes x squared minus 6x plus 9 equals negative 5 plus 9. Okay, so I've added 9 to both sides. Now let's simplify that. Okay, so that's going to be, on the left, the simplification will be the perfect square factoring. That was the whole reason we did this, right? They're not like unrelated events. A lot of times students just memorize this process as a series of steps that seem like unrelated. I don't know, I do this, then I'm told to do this, then I do this. The reason we take half the coefficient, square it, and add it to both sides is because it forces the left to factor as a perfect square. And sometimes students get caught up on, oh, well, how do I factor that? I don't remember. You know how it's going to factor. It's going to be x and then whatever half the coefficient is. So in this case, it'll be x minus 3 squared equals 4. Because negative 5 plus 9 is 4. Okay, so using the square root property, I get that x minus 3 is equal to plus or minus 2. Adding 3 to both sides, I get x equals 3 plus or minus 2. Now, in this case, like, you never leave an answer as 3 plus or minus 2, because you know what 3 plus 2 is and you know what 3 minus 2 is. So is this the simplest form? No, it would make more sense to just say 5 and 1, right? 5 and 1 being the answers. So when you get a nice integer answer like 5 and 1, that means we could have factored this from the beginning, but I kind of warned you about that. The point of this example was not to get the answer. The point was to see how completing the square works on a simple problem where you're just kind of, you know, a minute ago we dipped our toe in by just figuring out what value should be added to both sides. Now we're kind of putting our whole foot in by seeing into the pool by saying, okay, how do I use completing the square on a simple problem? And then you'll move along to where you're doing the hard problems like I showed a minute ago on how to do that. So let's see. This should be 5 and 1. And we got it. Okay? And they walk you through that whole process. Okay. What do we have? About 8 minutes? Okay, so wait, isn't this the same problem? No, this is a little bit different, but I think, no, this would be slightly different, but I don't want to do that one because that's going to be pretty much the same problem again. Okay, so here's what I'm going to show you. Here we have completing the square where your lead term is not a 1. That's a little more complicated, and I'm not going to be able to go over that in 8 minutes. So what I'm going to have you do is watch the help video and see what they do here. We have to modify our work a little bit. It's going to get a little bit messy when we do it. Basically, actually, this one was set up. I didn't notice that at first. This one was set up pretty nice. Like in this case, what you'll do is you'll divide everything by 5. See how the entire equation can be divided by 5? That makes it so it's not too bad. Sometimes the thing you divide by is going to create fractions in the rest of the problem. It doesn't really change the problem. It just means now everything is a fraction, which is a pain. It's totally a pain to do the problem that way, but that's going to happen. In this case, you don't have to worry about it. Like here, well, let me show you the solution. See, the first thing they do is divide by 5. And then now we have an equation that looks kind of like what we've been looking at. So then you're going to move things around, put it in square root property, go through the completing the square, solve, and then get your answer. But that's pretty long. Look at this solution. That's a lot going on. So you just have to kind of be prepared for the fact that these problems are going to have a lot more writing than the previous problems. Okay? That we've done in this book, like the factoring. A lot of those times you wrote 1 or 2 lines in order to do the problem. This one has what? I mean, you wouldn't need to write all the lines they have here, but that's what, like 20 lines maybe? It's a lot more going on. Let's see. Quadratic inequalities. Let's take a look. So there's a question here about homework coming up. Quadratic inequalities due November 25th. Yeah, so I think quadratic... Yeah, I think that's one of those topics where, like, I'm probably not going to be able to have time to cover in class because I definitely need to cover composition, inverses, and logs, and exponentials. We're gonna be flying through that material. That's one of those cases, kind of, and that's a good question. I'm glad it was asked. Let's see. The 25th is, what is that? Thursday. Let's see. Let me look at the calendar really quick. That's a good question. That's Thanksgiving. Why don't I'm going to move some of those due dates to be the 28th. That will give you a little bit more time to work on that homework, but it's kind of the thing I've mentioned a little bit or throughout the semester, which is because we're an online class, we meet in a lot fewer hours. I don't have time to cover everything. So I'm kind of choosing the things that I know from in the classroom, or the things that students struggle the most with are the ones I'm choosing to cover, but I won't be able to cover it all. So I'm going to make myself a note to extend MV03 homework until the 28th. So that gives you a few extra days to do those homework assignments, but unfortunately, I'm not going to be able to devote an entire class session or even a part of a class session to talking about those things because we're just moving too quick. We have to, because we only meet 2 hours a week instead of the normal 5 that we would if this was like a traditional on-ground course. So, yeah, I'll extend those due dates until Sunday, right? Because I get it. Most of you probably don't want to be sitting in front of a computer on Thanksgiving trying to get your homework in by the due date. Okay, so then there's a question about the math final. Yes, so remember, math finals are posted, right? They're all posted right here. So if you go to the top of the Ventura College webpage, see where it says academic calendar? If you click that, Then you go down here and it gives you your final exam schedule. So you click that and then you have your final exam schedule. So this is for all your classes, not just my class. So, but our class would be in here. So we're what? We're Monday, Wednesday at 10 a.m. Is that right? So Monday, Wednesday at 10 a.m. appears like it's going to be, so the column is the day and the row is the time. So that Monday, Wednesday at 10 a.m. means you have a final exam on the 15th of December from 10:15 to 12:15. Yeah, and I wasn't trying to get on anybody's case. I know I was just pointing it out so because it's a thing that people forget when we have these classes that I don't have time to cover all this stuff. So I just, because I get emails about it and stuff, so I just kind of throw it out there to remind people. But yeah, so that's when, there was a question about the final exam time. You can look that up. You can also look up all your other classes. You just look at the start times. So we're Monday, Wednesday at 10. You find that. Column is the day. Row is the time. Okay, so if you have an English class, you can look that one up, and you have a, whatever class, you can find that one. All right. So yeah, so you're all good to go. Okay, so with that, we'll wrap up. Anyone who wants to talk to me, feel free to hop into Zoom. Otherwise, I'm going to go drive to school because I'm going to have to do at least part of my office hours there today because I have to get those documents for my department head. But if you have a question, just stick around now and I'll answer your question right now before I go. Okay. Yeah, and thanks everybody. Have a good Thanksgiving. Be safe, right? It's kind of weird. We're still in a pandemic. It's easy to forget that when you're all happy to see family and stuff, but no one wants to spread anything to their family members. So be smart, be safe, and enjoy your Thanksgiving, right? Enjoy that for a bit. So thanks everybody. We'll see you. I guess I'll still see you though on Wednesday, right? We still have class Wednesday. Wednesday is not a holiday. Thursday is, but not Wednesday. So we can still talk about stuff on Wednesday. Okay. Thanks everybody.